Welcome to section 2.7. We're doing nonlinear inequalities. This is a brand new section for us. This is not something we've seen in Algebra 2. So I want to start off with this idea of this intro. Basically looking at an inequality, x squared minus 2x minus 3. And our goal is, when do you get a negative answer? Okay? And so what you would want to do is kind of just play with some numbers. When do you get negatives? Well, if I plug a 0 in, then 0 squared is 0, minus 2 times 0 still is 0, minus 3 is negative 3. If I plug a 1 in, 1 squared minus 2 minus 3 is still a negative, and so is it when I get 2. And you could find a lot of possibilities. I mean, you could try negatives, you could do, there's a ton of possibilities. But the question is, how do we find all of them? Because we're not going to ask you for specific answers. We want all of the answers. And so here's what we're going to do. I'm going to walk you through a process. The first thing we're going to do is find the zeros. Okay, so we're going to take our polynomial, x squared minus 2x minus 3, and we're going to set it equal to 0. And in this case, you can factor this, x minus 3 and an x plus 1. And if I set it equal to 0, I get that x is 3 and x is negative 1. These are what we call critical numbers. And these critical numbers are going to help us set up what we call test intervals. And so what I'm going to do is show you a number line so that you can see our intervals. The goal is to find the intervals, and then we're going to set up a table. And so I'm going to make this number line. Okay, here's 0, 1, 2, 3, negative 1, negative 2, negative 3. And I'm going to show you this just a couple of times, and then I think you'll kind of figure out how to do intervals. But this says that there is a 0 at 3, and there's a 0 at negative 1. And by putting these dots on the number line, you have basically just cut your number line into 3 parts. This is your first part. Here's your second part between the two values, and my third part is what happens on the other side of the 3. And so what I'm going to do is going to help you set up what we call an interval table. So the third thing we're going to do is make an interval table. This table is a must. You're going to have to do this on the quiz for me anyways, and so I want to get you in that habit. The first thing we're going to do is put our intervals. Then we're going to pick a point, and then we're going to say, okay, did I get a positive number or did I get a negative? And I'm just going to set up this table. My intervals are from all the way left until I get to negative 1. So that first interval is from negative infinity to negative 1. My second interval happens from negative 1 until I get to 3. And right now I'm not concerned with brackets or parentheses. I just want to test between those points. And the third one is from 3 and above, so from 3 to infinity. And when you do your intervals, I don't want to include the endpoints because the endpoints will give me 0, and that was the whole point of factoring. So what we're going to do is pick a number in between negative infinity and negative 1. Make this easy on yourself. I'm going to pick negative 5. And when I plug a negative 5 back into my polynomial, the question is, what type of answer do you get? Now what you could do is go in your y equals x squared minus 2x minus 3, and then look at your table. If I look at my table at negative 5, do I get a positive or a negative answer? I get a positive answer. If I pick a number from negative 1 to 3, I'm going to pick the easiest one I can, 0. And we showed above that 0 would get us a negative answer. And the third one, pick from 3 to 0 or 3 to infinity, I'm going to pick 5 again. This ends up getting me a positive answer. My goal was to get a negative answer because I want it less than 0. So I'm looking then at this interval. And what I want to know is, should it equal 0 or should it just be less than? In this case, that says less than, so I don't want it equal to, which means that my solutions happen from negative 1 to 3, not including the endpoints, because the endpoints would actually equal 0. And if I put this on a number line, because boy do they want that, here's -1, here's 3, I know 0, 1, and 2. Again, don't just put a couple of points. Because I'm not including -1, I do an open circle at -1. Because I'm not including 3, I put an open circle at 3. And I'm shading between these. This is what I'm going to write for my solution. Both the interval in interval notation and the number line. Okay, and you'll have 2 answer blanks like that on your quiz and on your test as well. So this is the answer that we're looking for, and again, it's 2 parts, an interval and a number line. Okay, so we're going to do the second one. The second one gets a little harder. You will need your graphing calculators. What we're going to do is say, okay, I have 2x cubed minus 3x squared minus 32x, and I'm going to move the 48 over, so positive 48 is greater than or equal to 0. You need it to include 0 because I want to know, do I just want a positive answer or do I want a negative answer? Once I go here, I'm going to go to my graph and I'm going to find all of the zeros. Because my degree is 3, I know I should have 3 zeros. So I go to my graph. One of the zeros is at -4. The other 0 I can see is at 4. The third 0, you probably need to use your calculate function or change your table, but the third 0 occurs at 1.5. Okay, so here's what we're going to do. We're going to put these on a number line again. I want to look at how does this split up my intervals. After this, I probably won't anymore, but just until we can kind of see how it splits up. 1, 2, 3, and 4. Okay, so at -4, I have 1. At +4, I have 1. And at 1.5, I have 1. So you'll notice now it splits it up into 4 parts. 1, 2 is in between, 3, and 4. So I'm going to make my table again. Okay, the first one is my interval. The second part is my point. And then I'm asking, do I get a positive or a negative? Well, I have anything less than -4 means from -infinity to -4. And then I have between -4 and 1.5. I get then from 1.5 to 4. And my last one goes from 4 to infinity. Okay? Again, your tester point doesn't have to be the same thing as your neighbor's. It's fine. But I'm going to pick as many easy ones as I can. I'm going to go at -5 between -infinity and -4. And again, if I stick this function right here in my y equals menu, what I can do then is I can hit trace and actually find the value, or I can look at my table. At -5, I get a negative answer. Between 4 and 1.5, I'm going to pick 1. I get a positive answer. From 1.5 to 4, I'm going to pick 2. I get a negative answer. And from 4 to infinity, I'm going to pick 5. I get a positive answer. And once I make my table, again, the goal is, what do I want? And so I go back to my inequality, and I'm saying I want positives. So I'm looking at this interval, and I'm looking at this interval, which means I have multiple ones this time. Do I want to include my endpoints? Do I want parentheses or do I want brackets? Because it's greater than or equal to, I want brackets. So when I go to do my solution, 2 things. We want our intervals. So from -4 to 1.5 including, because again, I want it equal to 0. And from 4 to infinity, and infinity never gets brackets. Please be careful with that. So there's my solution. Again, we're asking you also to put it on a number line. So let me fill this out. Okay, so from -4 gets a dark circle, a closed circle, to 1.5 gets a closed circle, and I shade in between these. And then from 4 on to infinity, and I'm just going to darken in the arrow, this then is my solution. And again, your solutions are 2 parts. First is interval notation. Second is going to be your line graph. Okay, so that gives you kind of an indicator of what we're doing. I'm going to show you a different type on the back, but I want to talk about some special cases. These are some weird ones, okay? And I say weird more so because what we can do is just look at the graph. Okay, and you'll see kind of why we talk about just looking at a graph in a minute. But if you look, x squared minus or plus 4x plus 8, stick that in your y equals menu, and what you end up getting is a graph that looks something like this. Okay? And the question is, when is this going to be positive? Well, there are no zeros, right? I mean, I don't have anything that touches my x-axis. And what you'll notice is it's always above the x-axis, so it's always positive. Therefore, always, we say by saying from negative infinity to infinity. Okay, it is always going to be positive because it's always going to be above the x-axis. In part B, again, I would stick this in your y equals. We're asking when is this going to be negative? Okay, so I graph this, and I don't know, general shape, let's go something probably like this. When is this going to be negative? Never. Right? It's never going to be negative because, one, it doesn't touch the x-axis and it's never down here. So the way we say never, we don't actually say never, we say no solution. Okay, this is the idea of infinitely many solutions. This is the idea of no solution. So let's look at C. Okay, if I go to graph this one, you have a 0 at -1, so my graph looks something like this. And the question is, when will this be less than or equal to 0? Less than or equal to 0. Well, the less than part, not happening, right? But the equal to part, absolutely I'm equal to. Where am I equal to 0? The only solution is at x equals -1. Because the only way that I'm less than or equal to is right on the x-axis, and that occurs at -1. Okay, final one. Let's take a look at this. As I look at this graph, again, I'd stick it in my y equals x squared minus 4x plus 4. We have a parabola that touches the x-axis at 2, so it looks something like this. And our question is, when is this positive? Okay, so we have an issue. We have this 0 here. We don't want it to be 0. We want it to be positive. And it's going to be positive everywhere else except at x equals 2. So how do we basically say all reals except 2? We have to break our interval up into 2 parts. When I look at the left-hand side, it's from -infinity to 2, not including it. And we have to look at this right-hand side, which is from 2 to infinity, and again, you can't include it. We don't want that 0 part there. Okay, so those are the ones that are kind of a little different. What you can do is, you could start always by looking at a graph and seeing, is it one of these special ones, or do I actually have to make an interval table? So go ahead and flip the page. Let's look at the second half. The second half is talking about rational inequalities. We've talked about rational functions. They're fractions. The goal is to find the zeros for both the numerator and the zeros for the denominator. Both of those are called the critical numbers. And we looked at critical numbers before as just being the zeros. And in this case, we're looking at the zeros for both the numerator and the denominator. But before I can find the zeros, we first want this equal to 0. So 5 plus 7x over 1 plus 2x minus 4. Oh, not equal to. Let me change that a minute. It is just less than 0. Okay, but I can't find the zeros of the numerator and the denominator without having just one numerator and one denominator. And so what I'm going to do is make a common denominator. I'm going to multiply by 1 plus 2x on top and bottom. And when I distribute this, this negative 4 goes to the numerator. So I have something over 1 plus 2x. I'm going to go one more fraction at the end, I think. So I have a 5 plus 7x. Negative 4 times 1 is negative 4. Negative 4 times 2x is negative 8x. And let's simplify this one more time. 5 and negative 4 is 1. 7 and negative 8x is minus x over 1 plus 2x. Okay, so this is actually the function now we're going to be working with. And so my goal is to find the zeros. So let's do that first. I can find the numerator, 1 minus x equals 0. Therefore, x equals 1. And I can find the denominator, 1 plus 2x equals 0. 2x equals negative 1. So when I divide by 2, x is negative 1/2. So these are my two critical numbers. And if I talk about them in terms of a number line, I'm not going to draw a number line. This time what I'm going to do is just put up my intervals. But let me go through again, what did we do? First we made one fraction, okay, and we set it equal to 0 basically. So we got the number by itself made one fraction. The second thing we did is we found our zeros for both the numerator and the denominator. And then the third thing we're going to do is set up our test interval table. And then we'll find our solution. Okay? This table, again, guys, if I had a way around it, I would, but you have to show me the table. So I know my intervals. I have 1 from negative infinity to negative 1/2. From negative 1/2 to 1. And then from 1 to infinity. Get rid of some of this stuff again. From 1 to infinity. Okay, and we're making our intervals. We're going to pick a point, and then again we're going to ask, do we get a positive or do we get a negative? Between negative infinity and negative 1/2, I'm picking negative 5. At negative 5, you get a negative answer. In between negative 1/2 and 1, I'm going to pick 0, and you get a positive answer when I put that in my y equals. And if you're asking, what do I put in my y equals, this is the fraction you want to put in your y equals. Just make sure you have parentheses on top and bottom. And the final one, I'm going to pick 5, and you get a negative again if I'm looking at my table. And so we again have to ask ourselves, what's the goal? And I go back to the goal and I want the negatives. And I don't want to include them because it's only the less than. So if I want the negatives, I'm looking at these two intervals. So the last step is my solution. My solution, I don't want to include them, so from negative infinity to negative 1/2, and from 1 to infinity. And again, if we asked you on a number line, let's do it. We're going to make it easy. Negative 1, 0, and 1. I have an open circle at 1 going to positive infinity. And I have an open circle at negative 1/2 going down to negative infinity. Okay? So this then is my solution. So we've shown you basic interval tables, some of the different ones, and now we've shown you a rational function. The last thing we're going to show you is what happens with a square root. So what we're going to do is, I'm going to slide this down a minute. What happens with a square root? And while I'm thinking of this, again, I'm going to cross this out. Please look at your schedule because they do tend to modify the homework assignments off these. So look at your schedule as you're going through. When you talk about the domain of a square root, the biggest thing, and we've talked about this last chapter, 4x squared, it can't be negative because you can't take the square root of a negative number, okay? And so this is actually what we're trying to solve. Is this more than the square root function? We want to know, when do you get positive numbers? So what I'm going to do is I'm going to actually find the zeros, or find the critical numbers first. So 64 minus 4x squared is greater than or equal to 0. And I'm going to go through and solve. So 64 equals 4x squared. And I'm actually, to find the 0, sorry, I'm going to set it equal to. So I get 16 equals x squared. And when I square root, x is a positive and a negative 4. And so these two are my critical numbers. Critical numbers. Okay. So let me set up my interval table. Okay, I have my interval. I'm going to pick a point, and then I'm going to decide, is it positive or negative? So I have a 4 and a negative 4, which means I have 2 critical points. That means it's going to split my number line up into 3 intervals. So from negative infinity to negative 4, from negative 4 to 4, and from 4 to infinity. Okay, and again, you can pick any values you want within those intervals. I go for the easier ones. I'm going to pick negative 5, 0, and 5. And if I stick in my y equals 64 minus 4x squared into my y equals, then you can help find your table. At negative 5, I get a negative value. At 0, I get a positive value. And at 5, I get a negative value. So I go up to my original equation, basically, and I'm looking at this equation here. I want the positives and 0. So I want this middle interval. Because it can be equal to 0, my solution then is going to have the brackets. So my solution is from negative 4 to 4, including those values. And if I make my number line, get as creative as you want. Closed circle at negative 4, closed circle at positive 4, and I shade in between. This then is my solution. And so when you're dealing with square roots and they ask you about a domain, you have to set up the inequality yourself and then do the same process again. Okay, again, circle star any questions you have. Thanks for watching section 2.7. This is the last section in chapter 2, so we'll start chapter 3 in a couple of days.